Intel recently released their 9th gen CPUs with further core count increases, thus bringing the core war a bit closer. Now, these CPUs really are reaching the limits of Intel's manufacturing process, with 8 cores being able to reach the 5 GHz mark. This means AMD really does need to step up the game in order to compete at the top of the product stack. So could they? Well, before I answer that question, I'm Hakaru, and this will be an investigation into whether or not Zen 2 could reach the sought after 5 GHz mark. So a few videos ago, I said this about my predictions for Zen 2's architectural improvements. That is very likely that the Zen 2 architecture will have a front end capable of driving most of the core's back end. Don't forget, Zen was built from scratch in just 5 years, so imagine what kind of work can be done in just 2 from the front end. There, I specifically mentioned that Zen 2 will likely have a rebuilt core front end, as in the video I concluded that Zen is held back by its core's front end, and about 2 weeks after that video, AMD held their next Horizons event, essentially solidifying what I said in that video. There they showcased their next line of server chips known as Rome, and they also showcased their new 7nm Vega GPUs, both of which will be an important part of the rest of this video. But first, turning to Rome. Built on Zen 2's architecture, AMD released some information about the product on their website saying, quote, "Front-end advances, improved branch predictor, better instruction prefetching, re-optimized instruction cache, and larger op cache," unquote. This is what solidifies the conclusions of my earlier video, but also note where it says larger op cache. In my earlier video, I say this about Zen's op cache. When it comes to the decoded micro op cache, the Skylake CPU can have up to 1536 entries over 32 sets. However, the Zen architecture has a capacity of 2048 micro-ops over the same 32 sets, because each set in a Zen CPU can store up to 8 micro-ops each compared to Skylake's 6. Both architectures use 8-way associativity. What this shows us is the Zen architecture was built for wider cores, having a wider decoded micro-op cache and not necessarily faster cores. Now, if we look at the part on AMD's website where they say that this architecture will come with a larger op cache, I find it very likely that this means a longer op cache and not a wider op cache. This is because Zen's original op cache was already 33% wider than on Skylake. These length increases will allow the CPU to operate at higher frequencies by allowing for deeper prefetches. Now, deeper prefetching and longer queues mean you need to get a better branch prediction, which is also being improved according to AMD's website, so it does look like AMD are gearing up for higher clocks than before. But do remember, 4.5 GHz is higher than 4.1, so this won't exactly answer our question as to whether Zen 2 can do the magical 5 GHz. It just answers if AMD is building up for more than 4 GHz, and the answer is yes. Next, we need to make predictions about what the clocks Zen 2 could reach are. To do that, we need to look at AMD's new Radeon Instinct MI60. So the MI60, other than having a terrible name, this GPU is the first 7nm GPU, if you could call it a GPU. It is Vega based. However, there are some pretty decent differences between this Vega and the ones found on the MI25, but that's off topic. Anyway, it is Vega based with 64 compute units and a 4096-bit HBM2 memory interface, providing an absolutely insane 1 TB per second of memory bandwidth. That's the same as the L1 cache of an 8-core Ryzen CPU at 4 GHz, but more importantly are the other facts that we know about it. It runs at around 1.8 GHz, has a 300W TDP, and can do 14.7 teraflops of single precision workload. Now, why does this matter for Zen? Well, I'll come to that soon enough. But we know the specs of the MI60. Let's go back to the MI25, the old top-tier product launched nearly a year ago. The MI25 also packs 64 Vega cores, sits on a 300W TDP, but packs a slightly smaller 12.29 teraflops of single precision flow performance. Now, I don't know what the exact clocks of this thing are, but we can work them out from AMD's official numbers. So first, we'll work out the MI60's clocks just to make sure our methods are correct. Then we'll do the MI25 to calculate its clock speeds. So the formula to work out the flops is the frequency times 2 times the number of stream processors. If we rearrange that equation, we can make the clock frequency the subject of the formula. Using the new equation, 2 times the stream processors divided by the flops gives us the inverse of the frequency. If we then 1 divided by our answer, we ought to get the clock speeds of the GPU. So let's give it a go. Both GPUs use 64 compute units, giving them both 4096 stream processors. So to work out the MI60's clocks, we do 2 times 4096. We then divide that by the number of teraflops, which is 14.7. That gives us the inverse of the clock speeds. If we do 1 divided by that just gives us the clock speeds, which is about 1.8 GHz, as stated on AMD's website. So that's the proof that this method works. Let's use it to work out the clock speeds of the MI25. So, 2 times 4096 divided by 12.29, and then 1 over the answer, gives us 1.5 GHz. So again, you might be wondering why this matters to Zen. Well, I'll tell you. Zen 2 is going to be built on this process. That means if we work out the performance increase from a 14nm part to its identical 7nm part, i.e. both 64-core Vega-based 300W GPUs, then we can apply the same logic to go from a 14nm CPU to an almost identical 7nm part. So if we work out the performance increases from the MI25 to the MI60, we find going from 14nm to 7nm gives us 20% clock improvements, importantly in the same 300W TDP. That means, in the same power, the clocks have risen by 20%. So if we take a 4.1 GHz Zen CPU, which is the top boost speed of a 14nm Zen CPU, and multiply that by 1.2 to increase it by 20%, we find that theoretically, going from 14nm to 7nm could net a 4.9 GHz clock speed at the same TDP. Okay, so we're getting close, but remember, the Ryzen 7 1800X had a TDP of 95 watts, and the 2700X had a TDP of 105 watts. Those extra 10 watts could be enough to scrape a Zen 2 CPU over the 5 GHz mark. Although I say could, because remember, there have been architectural changes that could have had a negative effect on performance, or maybe TSMC's 7nm process just won't reach 5 GHz. We've not seen this process before, so we don't know anything about its clock scalability. Also, according to Adored TV, Rome will have double the L3 cache per chiplet than what is on a Zen Zeppelin. That ought to increase the power consumption at the same clocks, but remember, on the upshot, AMD were building these cores for higher speeds than before, so really, there are too many variables to call. I'd hedge my bets on 4.8 GHz being achievable. 5 GHz might be possible, and I expect AMD will try really hard to get to that 5 GHz mark, if just not to say that they did it. But I guess only time will tell. Remember, Rome wasn't built in a day. Anyway, this one had been an interesting thinker. Hope you enjoyed as much as I did, and hope you learned something.